In today's machine learning class, we will see the solved problem of decision tree algorithm. This is the extension of our previous class. And from third unit, supervised learning classification, let us see the decision tree algorithm solved problem with the given data. And here we will learn searching a decision tree and calculating the entropy and information gain of a decision tree. Here, the global technology solutions will come to a college for hiring BE BTech students based on their interview performance. Okay, and this is the data set which contains the interview evaluation results of the student. Okay, which contains four important attributes. First one is CGPA. Here, three different data are there: high, medium, low. Okay, CGPA contains high, medium, low. And second one is communication. When come to communication, two important data are there: good and bad. Okay, two categories of data. And the third one is aptitude. When come to aptitude, high and low, two different attributes are there. And programming skill, good and bad. This is the fourth one: programming skill, good and bad. Okay, based on these four attribute, they will offer a job. Okay, offer a job, yes or no. Hence, this is the target attribute. Of job offered is target attribute. From this we can understand whether the particular student is getting the job in global technology solutions or not. Okay, here we don't have the name because the name is not helpful for predicting the job offered or not. Okay, so we omit this particular field, that is name. All the other fields we have taken for computing whether the particular students will get job or not. Now let us see the problem statement. So this is the given data, for example, training data. Training data, right? Now, a new student Chandra from the same college wanted to find the job in global technology solutions. Okay, the details of Chandra are: CGP is high, communication is bad, aptitude is high, programming skill is bad. Okay, so with this data, let us try to find whether Chandra will get a job offer or not by using the decision tree model. And next, let us try to draw the decision tree for the given example. So this is the decision tree. Okay, here we can take this aptitude attribute. If the aptitude is low, then they won't get job. See, if the aptitude is low, then they won't get job, because this will give very high information. Directly we can declare aptitude is low, then they won't get any job. So we will start from here. First we will check attribute aptitude. If aptitude is low, then job not offered. Okay, then we need to check what about aptitude is high, then communication. If the communication is good, okay, communication good, high aptitude, then they will get job. See, communication is good, aptitude is high, then they will get job. Okay, so aptitude is high, communication is good, then job will be offered. Okay, what about if communication is bad? Okay, next we will check the CGPA. CGPA is high, medium or low. Okay, if CGPA is high, communication is low and aptitude is high. Okay, high, communication is bad, aptitude is high, then yes, job is offered. Okay, job is offered. If CGPA is low, then job is not offered. Okay. With this above diagram, let us try to find whether the student Chandra will get the job or not. Okay, this is the given data for Chandra. First, we need to check aptitude. Okay, aptitude is high, isn't it? So from start, we need to check aptitude. Aptitude is high. Next, we need to check communication. What about communication? Communication is bad. Communication is bad. Okay, and next we need to check CGPA, isn't it? So CGPA is high. What about CGPA? CGPA is high, then job is offered. So the candidate or the student Chandra will get job from Global Technology Solutions. And next, let us see the decision tree implementation. There are many different types of decision tree implementation. First one is C 5.0 and CART, that is classification and regression tree, and CHIDE, that is chi-square automatic integration detector, and ID3, this is very popular one, that is iterative dichotomist 3 algorithm. Here, the very biggest challenge of decision tree algorithm is to find out which feature to split upon. That is, we need to select which particular feature to split the data. Okay, which contain the example, that is data items belongs to single class. That belongs to single class split. Okay, then this particular partition is called as pure partitioning. This is the very big challenge for implementing the decision tree. While implementing the decision tree, two measures are very important. First one is entropy and second one is information gain. Entropy means the measure of impurity of an attribute. Impurity of an attribute. Okay, based on this only we can select the particular feature for splitting the data set, and many of the algorithm like ID3 and C 5.0 are used to this entropy for the split. And second one is information gain. Okay, by using this entropy we can compute this information gain, which is calculated based on decrease the entropy. Okay, after a data set is split according to particular attribute A. Okay, so based on the entropy, we need to compute the information gain, and these two are entirely opposite to each other. Okay, entropy is impurity of attribute, information gain will give the highest value. If the information gain is more, we can select that particular attribute. Okay, so constructing a decision tree is finding an attribute, that returns highest information gain. Okay, then we can select this attribute for splitting the data. First, let us compute the entropy of decision tree. Okay, so here S is nothing but the sample data set or training data set. Okay, training example given in the problem, and we need to find the entropy of S, that is measuring the impurity of S, which is defined as entropy of S, which is equal to summation of I equal to 1 to C minus Pi log Pi base 2. Okay, so this is the entropy formula. Here, this particular C is nothing but the number of different class labels. Okay, in that particular attribute. And P is nothing but, this P is nothing but the proportion value falling into ith class label. Falling into the ith class label. So, by this way, we can compute the entropy of decision tree. And now let us find the entropy of the decision tree. Here the target variable is job offered. So the job offered is having two values, yes and no. So the entire data set, the job offer is having two values. Okay, so this is the training table, training data table, and total 18 records are there. In this table, we are having 18 different records, and now we need to compute the p value. Okay, so first let us take S, only the S records. Okay, in the total 18, 8 records are having S value. Okay, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, total 8 records are having S value, and the value is 0.44, that is 8 by 18. 8 by 18, 0.44. And next, the class value no is 0.56. So totally how many no records are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 records out of 18, isn't it? So 10 by 18, which is equal to 0.56. And right now we calculate the entropy. The entropy of S, which is equal to minus 0.44 log of 0.44 minus 0.56 log of 0.56. Okay, so we directly apply these values into our entropy formula. So the value is 0.99. The entropy of job offered is 0.99. The next one is information gain. Here the information gain for a particular feature A is the difference between entropy before split with the entropy after split. Okay, so the information gain S comma A. S is a data set, isn't it? And A is attribute. So information gain of S comma A, which is equal to entropy before split minus entropy after split. Okay, here for calculating entropy after split, the entropy for all partitions need to be considered. This is important. Okay, and the weighted summation of entropy for each partition can taken as the total entropy after split. And for performing the weighted summation, the proportion of examples falling into each entropy is used as weight. And we will understand all those things while seeing the example. Okay, now the formula for entropy after split is summation of I equal to 1 to n wi entropy of pi. And now let us try to compute the information gain for our given training data set, right? And for computing the information gain, we need to calculate the entropy and the difference between before split and after split is our information gain, isn't it? Here we need to compare the value of all cases. The first one is the first feature, we take CGPA. CGPA is our first case, and communication, aptitude, programming skill. So we need to consider all the attributes and these should be compared with job offered. Okay, which one is giving very high information gain? We need to take that particular attribute for splitting our data set. Now let us try to compute the entropy of all given attributes. So initially, that is before split, the entropy is 0.99. We have already seen. Okay, that is total number of records we are having is 18, and the job offered yes is total 8 records and no is total 10 records. Okay, that is job offered yes is 8 records and no is 10 records. Okay, pi value is 0.44, that is 8 by 18, and 0.56, that is 10 by 18, and the entropy, okay, minus pi into log pi, which is equal to 0.52, and here this is 0.44, and the total is 0.99. So this is what we have computed yearly. Okay, this is entropy before split. And now let us compute the entropy for all the other attributes, that is after split, with respect to job offered, how the CGPA will be. Okay, here first let us take CGPA equal to high. So how many CGPA high is there? Total 6. So high 1, 2, 3, 4 and 5, 6. Total 6 records are there. So under this 6, how many records will fall under job offer yes, and how many records fall under no? No. Here totally 6 records, that is 4 records are under yes and 2 records are under no with the CGPA high. Okay, now let us try to compute the pi, that is 4 by 6, which is equal to 6.7, and 2 by 6, which is equal to 0.33, and now pi log pi, which is equal to 0.39 and 0.53, and total is 0.92. Okay, now let us try to compute the CGPA medium. Okay, now we need to apply the same here. The total CGPA medium is 7 records. Okay, 1, 2, 3, 4, 5, 6, 7. So total 7 records there. So under these 7 records, 4 records will fall under yes, that is job offered yes, and 3 records will fall under job offered no. Job offered no. Okay, so this medium will come under yes, and this medium will come under no, job offered no. Okay, likewise this is the total, and the pi which is equal to 4 by 7 which is equal to 0.57 and 3 by 7 which is equal to 0.43. And now let us try to compute this minus pi log pi which is equal to 0.46 and this is 0.52 and sum of these two is 0.99. Okay, and CGPA low. If CGPA is low, then no job will be offered. See, whenever we have CGPA low, then no job is offered. See, low, no. Okay, so total number of records are 5. For all the 5, the job offered is no. Hence, the entropy, that is the pi log minus pi into log pi which is equal to 0. Pi value is 0 here. Now we need to compute the entropy value. Okay, so the entropy for after split is this one. Entropy after split which is equal to summation of I equal to 1 to n Wi entropy of Pi. Right? Wi is nothing but weight. Wi is weight. Okay, now total records are 18. Under this 18, CGPA high is 6. So 6 by 18 into entropy is 0.92 into 0.92 plus here total number of records are 7, that is medium is 7 and total number of records equal to 18 into 0.99 and here this is 0, so we need to sum these two values, so the value is 0.69. So this is information gain, that is entropy. So from this entropy we need to compute information gain. What's the value? Before entropy minus after entropy, that is 0.99 minus 0.69 which is equal to 0.30. So this is the information gain for CGPA. Okay, likewise we need to compute the entropy and information gain for communication. See, when come to communication, there are two attributes. One is good and second one is bad. For good, 9 records are there. Under this, 7 will fall under yes. Okay, good 9 records are there. In total 9, 7 will fall under yes and 2 will fall under no. Okay, likewise we need to compute pi and pi log pi. Okay, so the pi log pi for communication good is equal to 0.76. Likewise, the pi log pi for communication bad equal to 0.50. So with this we need to compute entropy. The entropy of communication is 0.63 and information gain, that is 0.99 minus 0.76 which is equal to, that is 0.63 which is equal to 0.36. Okay, 0.99 is here, this is 0.63 which is equal to 0.36. Okay, likewise we need to compute the entropy of attribute, that is aptitude. Aptitude equal to high, aptitude equal to low. When come to aptitude, the entropy is 0.52 and the information gain for aptitude is 0.47. And simultaneously we need to compute the entropy for programming skill, good and bad. Okay, so the entropy of programming skill is 0.95 and information gain is 0.04. Under this, the information gain for aptitude is 0.47 which gives the highest value. Hence, we need to select the aptitude to split further. Right? So here, as we already seen, the calculated entropy before split is 0.99 and the entropy for data set after split. Okay, after split for CGPA is 0.69 and communication is 0.63 and the aptitude is 0.52 and the programming skill is 0.95. So likewise the information gained for CGPA is 0.3. So the information gained for CGPA is 0.3 and the information gained for communication is 0.36. See, and the information gained for aptitude is 0.47 and the information gained for programming skill is 0.04. Okay, among these the information gained for aptitude is 0.47 which is the highest value. So among all the values, the information gained for aptitude is 0.47 which is the highest value. Hence, in the decision tree development, let us take the aptitude will be the first node of the decision tree. Okay, so the aptitude. We need to check the aptitude first in the decision tree development. And one more thing, in aptitude law, S is 0 and no is 7, hence the entropy is 0 here. The entropy of low is 0 here. Okay, that means we can easily declare that aptitude is low, then no job will be offered. Okay, the tree will get stopped here. We need not search the other thing. If the aptitude is high, then only we can check the other attributes, right? In level 2 of decision tree development, we need to consider only aptitude equal to high. Okay, so this is aptitude equal to high. Total number of records are 11 and the entropy is 0.85. We have already computed in our previous table itself. For aptitude equal to high, the entropy value is 0.85. Okay, now let us try to compute the entropy for the CGPA. CGPA high with respect to aptitude equal to high, the value is 0. Okay, and CGPA equal to medium, the entropy is 0 is 0.72. And CGPA equal to low and entropy is high, then the value is 0. Okay, that means if CGPA equal to high and aptitude is also high, then every records will fall under only yes condition. Entropy is 0 here. Okay, now sum of all entropy is 0.33 and the information gain is 0.52. Okay, and this is for CGPA. Likewise, we need to calculate the entropy for communication equal to good and communication equal to bad. Here the information gain is 0.55 and after that we need to compute the same thing for programming skill good and bad. Then the information gain is 0.05. Among all those things, the communication will give highest information gain. So we can take this information gain as our second node. Okay, previously we are having aptitude. Aptitude is first. So if aptitude is low, then we can declare that no job will be offered. And if aptitude is high, then we need to check the communication skill. If communication skill is good, this is good, then job will offer, yes. Otherwise, we need to go for further verification, right? Now we'll move to level 3. We will start with aptitude equal to high and communication equal to bad. Okay, so this is the table for communication equal to bad, which is taken from second level. Okay, here the entropy of communication equal to bad is 81. We will start from here. Likewise, we need to compute the CGPA, which is equal to high, medium and low. Okay, so this is the entropy value for CGPA high. That is, if CGPA high, then job will be offered. If CGPA is low, then that is medium, no job will be offered. If low, then no job will be offered. Okay, so the entropy of CGPA is 0 and information gain is 0.81. Likewise, we need to compute programming skill good and programming skill bad. Here the entropy is 0.5 and the information gain is 0.31. So with these two, CGPA is having highest information gain. Okay, that means if aptitude is high and communication bad and CGPA equal to high, job is offered. Yes. Okay. If CGPA is medium or low, then no job is offered. We can declare directly. Okay. Here, the information gain for CGPA is 0.81, which is the maximum possible information gain. Okay, that means if CGPA is high, yes, that is job will be offered. If CGPA is medium or low, then no job will be offered, isn't it? So there is no need to continue further. That the tree growth will be stopped here. Okay, so this is the final decision tree. We will start with aptitude. That is the first one. If aptitude is low, no job will be offered, we can declare, and no need to search the further attributes. Okay, if aptitude is low. If aptitude is high, then next we need to search the communication. If communication is good, then we can definitely offer the job. Otherwise, we need to check CGPA. If CGPA is high, then job will be offered. If it is medium or low, then job will not be offered. Okay, so no need to check the programming skill. So far we have seen the solved problem for decision tree algorithm from third unit supervised learning classification. For that we have taken the training data set for the global technology solutions for offering the job for students or not. Okay, that is our training data set, and in the training data set we solved the problem by calculating the entropy and information gain. Okay, in the next class we will see the random forest algorithm from third unit. Thank you.